Hey everyone, today we are going to talk about domain-driven design in practice. I've prepared some images for you to for just brief explanation of domain-driven design. But our main focus is, of course, the practical one. We have Visual Studio project where I will explain how you can implement domain-driven design in practice. So first of all, before switching to our practice, let's try to understand what is domain-driven design. Domain-driven design is a software development approach. It is a software development methodology. Domain-driven design brings with it strategical and tactical patterns that you can use in your daily life when you apply domain-driven design. Of course, most of these patterns are not invented by domain-driven design guys, but they are collected together to make domain-driven design real. So first of all, you need to understand that domain-driven design in software development helps us to avoid translation between tech and business people. Why? Because in modern days, as you know, we are mostly focusing on translating requirements to the developer's language. And it is a big problem when you have non-technical guys and they are explaining, they are providing some task for you, and you are converting this task into code. And in this conversion process, you are losing a lot of information. And that's why we have domain-driven design. We are applying domain-driven design mostly for complex applications. It is not about the complexity of the technical stuff. It is about the complexity of your domain. If you have a complex domain, complex business logic, you can definitely apply domain-driven design. But if you have technical complexities, it is, of course, not preferred to use domain-driven design. Also, for your CRUD applications, please don't use domain-driven design, okay? So, as I mentioned, domain-driven design has two main patterns for us. One is strategical, the other one is tactical. Strategical patterns are the most important ones. We have ubiquitous language, bounded context, and context mapping. And when you apply strategical patterns, you are actually working on problem space. The problem space here is when you explore problem, you are not going to have a solution for it. You are just exploring the problem. You are trying to understand what is going on, what you are trying to achieve, what you are going to solve. This is going to be your problem space. On the other hand, tactical patterns are applicable when you solve this problem. So it is our solution space. So we have problem space, solution space. Of course, both really matters, but strategical patterns are the most important ones. So in domain-driven design, we have, as I mentioned, strategical patterns and tactical ones. We have bounded context, we have context map, we have ubiquitous language. They are completely a different session-based topics. We have tactical patterns like entities, value objects, aggregates, domain events, factories, repositories. In this tutorial, in this session, I'm going to show you how to apply these tactical patterns most, because I have already done the strategical part, and I will show you also how you can achieve using event storming, okay? What else? When you explore your domain, you have three main domains. You have core domain, which you need to focus on. You have generic domain and supported domain. You can ask someone else, another company, to solve the supporting domain problems. But for your company, you should focus on your core business domain. This is really important. And of course, for this session, I'm going to show you everything using clean architecture. So we have clean architecture, we have a lot of cool design patterns, we have domain-driven design, all of these stuffs together in one session, okay? Great. Now let's first switch to our event storming board. Before that, you can explore all these source codes just navigating to github.com/Suleimani. Here we have the real DDD, CQRS, and clean architecture, and we have more than 100 stars for this project. And I hope after exploring, you will also put star for this project. And here I have provided all the required information related to this application here. You can find all these, the basket app Miro link. You can find all these source codes. And plus, if you have least knowledge or if you are completely new in domain-driven design, below I have provided some tutorials. They are mine, and you can explore more about domain-driven design using these tutorials. And after that, you can switch to the source code to learn what's going on here. Okay, so great. Now let's switch to our Visual Studio. In our Visual Studio, after downloading, you will have this application structure. I have implemented clean architecture with domain-driven design, but please remember that domain-driven design is not strictly connected to clean architecture. You can host your bounded context. This is actually one bounded context. What is a bounded context? When you have domain models, you have conceptual boundaries where your domain models are valid, and this is called bounded context. Basket, in my case, is going to be my bounded context, my borders of domain models, okay? And for this bounded context, I can use different architectures to host it. Right now, I have applied clean architecture, but I may use layered architecture, onion architecture, I don't know, hexagonal, service-oriented, REST-based, etc. So that's totally up to you, not just up to you, but also up to the project requirement to apply the architecture, main hostable architecture. But for now, we have clean architecture. This is the most popular one. Let's work on that. So everything in domain-driven design starts with domain. This is applicable for clean architecture also. Our main project here is going to be Web Consulting Flame Basket Context domain. When you open this project, you will find some folders with some files. They are going to be my domain models. What actually domain models are? I have seen most times people are using entity framework models as domain models. For example, you have classes, and inside these classes, you have only properties, get and set properties. And people trying to move these classes to the domain folder and call it domain models. Of course, they are not domain models, first of all. I'm sorry for that, but they are anemic models. What is anemic model? Anemic model is when you have some sort of model that you think is domain model, but it actually consists of properties. It doesn't have any methods, so it doesn't have any responsibility related to this object. For example, in my case, I have basket. Let me zoom a bit. So I have basket. So you see, for my basket, I have properties like in your entity framework classes, but I also have a lot of methods. You see, I have add item, create, update item count, delete all, calculate shipping amount, calculate basket items amount, etc. So I have tons of methods here. This is actually domain model. So for my domain model, I haven't encapsulated the behavior of my class to the service layer. In most cases, what we are doing is we are creating our models, and over it, we are providing services. For example, for basket, you have basket service. Basket service encapsulates the logic related to basket init, and you are using basket for just table representation. Okay, so you have table with 4 columns, you have basket with 4 properties. This is actually a POCO model rather than your domain model. Your actual domain model should store the business. Domain-driven design say that in order to use DDD properly, you need to first focus on your domain. This is your core stuff. implement domain, and then switch to the external stuff like applying Apache, Kafka, Redis, etc. They are secondary. Most you should focus your core domain, because domain is everything. So context is everything, domain is everything. To achieve this process, you may apply different approaches. I have applied event storming here by Alberto Brandolini. I also have a podcast with Alberto Brandolini in my Tural Suleimani Tech YouTube channel. You may check this. We have talked a lot about event storming. So here in event storming, we are analyzing all this stuff together, okay? We are defining our entities, our aggregates, our constraints, our events, etc. All this stuff are defined here. In this session, we have technical guys, we have non-technical guys, we have domain experts, all in one, let's say. And after all this discussion, we are defining our main points, our strategical parent stuff like entities, aggregates, value objects. Mostly we're not focusing value object in event storming, but anyway. So after defining all this stuff and after defining all the main functionalities, we are switching to our code. In our code, we will have a lot of entities, value objects, aggregates, domain events, domain services, modules, etc. They are tactical parents. But please remember that domain-driven design is not about technology. Domain-driven design is not about coding. Domain-driven design foremost is about listening, bringing business value, learning, exploring, understanding the stuff rather than directly coding. Okay, first of all, you need to understand the domain. You or every software developer should be a really good domain expert. Why? Because you are not in your case, when you apply domain-driven design, you guys are not using translation between non-technical to technical. That's why we have zero translation. And this zero translation helps us to help business guys to learn more about the business. And also they are helping us to write a better code. This is the main key feature of domain-driven design. Okay, so in my case, I have baskets, I have coupons. So you see for my baskets and coupons, I'm applying aggregate root. What is an aggregate root? Aggregate root is a tactical parent applied in domain-driven design, which helps us to encapsulate entities and value objects in it. Your one aggregate root, one aggregate can consist of one entity or multiple entities, one entity with multiple value objects, multiple entities with multiple value objects. So it is up to you, it is up to the requirement to end up with the design. Okay, so first of all, let's switch to our basket item. My basket item is an entity. I will have a lot of entities in my bounded context, and I don't want to write this entity every time. That's why we have special project called Flame Common Domain. So you see Flame Common Domain. You can encapsulate it to a separate NuGet package. That's also applicable. And mostly you will do like this in your projects. You will encapsulate it to a separate NuGet package and will provide other squads to work on that. We have entity. This abstract class, you cannot instantiate it, but you can inherit from this entity. We are using a template method parent in this case. For every entity, we have ID, we have created at, we have last modified UTC. Okay. The case here is you can easily add the as much as properties as needed. In this case, that's total okay. For example, in your case, you may end up with just ID or ID created at, last modified at, etc., etc. Every entity identified by their ID, because your entity in your bounded context, the bounded context for your entity is going to be your aggregate root. Your entity's life cycle is defined inside your aggregate root. And your entity, you are able to instantiate this entity, to modify this entity, to delete this entity. So you see, we have a life cycle, a special life cycle, which we don't have in our value objects. This is really important. You cannot identify your value objects using by ID. You will have ID only in your aggregates and in your entities. Okay, so in my case, I have a general entity which encapsulates some logic like overriding, getting cache code, and having the related properties. That's good. When you inherit from basket item, you are adding as much as properties as needed in this case, but not just properties, but also the methods related to basket. So you say I have a create functionality, I have update count. Why update count? Because after carefully designing all this stuff, in our event storming, we are understanding that the update count is related to basket item rather than the basket itself. We are deactivating basket item, not basket itself. That's why we are encapsulating related logic in the related entities. This is really important. But in a classical development, what we are doing, we are just having POCO objects, anemic models, and we are moving all this logic to the service layer. We are having basket item service, basket service, coupon service, and more. But this is not valid for your domain-driven design. Just encapsulate the related logic in your case for your inside your entities and aggregate roots. Here I'm using the factory parent. This factory is also a part of domain-driven design. Of course, it was invented before domain-driven design, but just remember that domain-driven design doesn't bring a lot of new to the table. It is about using the proper ones in the given context. So we have factory parent, we have another parent, DDD just brings them to the table, and here you are, just use it. Why? Because I don't want to instantiate basket item every time using new, and I have easy one to wrap it to the factory and use via factory. Okay, that's good. Now here we have entity design parent, we have factory design parent. That's good. And for the construction process, of course, we are doing some sort of validation here. In my case, I have implemented all this validation as a separate library. So you see we have consulting, flame, common domain extensions. But if you feel comfortable and if it is okay for you to use the third-part validation tools, you are completely allowed to use it. That's up to you. That's up to your management stuff. Okay, so we have properties, we have validation stuff, we have a construction, and we have the related functionalities inside our domain model. That's great. It is applicable for all sort of entities. You see, I have customer. For my customer, I already implemented our entity. I'm inheriting from my entity. I have the related functionality. For my quantity, on the other hand, this quantity is also an object. I want to not to repeat the related logic in all sort of entities. That's why I have encapsulated it to a separate value object. Value object is also a part of domain-driven design. Value object, just let me open it. So you see this is also abstract class. You can handle value object creation using records. Of course, .NET allows us to create value objects easily using record keyword, but it is up to you. For the oldest .NET versions, you can use this abstract class value object. What is a value object? Value object is, let's say, a special form of entity. I can't call it actually entity. This is a class which can be identified by all its properties. So if you have 4 properties in your value object, these all 4 properties should be equal to all another property to make this object same. Okay, and for the value object, you can't use ID, because you cannot identify your value objects using ID. You are able to identify it using all its properties. That's why we have special template method approach called get equality components. And for your every value object, you are just overriding this functionality. For example, for my quantity, I'm overriding this get equality components, specifying that I have value, limit, price per unit. Okay. In your domain, you are encapsulating all the main logic related to your project. This is really important. If you handle domain, you're actually handling, let's say, 80% of your project. Okay, that's good. So for the common used stuff, it will be really good practice to encapsulate it to a separate library, like I did here with Flame common domain. I have aggregate root class with interface. I have date range, I have entity, I have ID. Why ID? You can use the simple int, ulong, etc. for your identification, but mostly in domain-driven design, we are using GUID. And for GUID, we have some sort of functionalities which we are using repeatedly. That's why I have encapsulated all this logic to a single class called ID. Okay, for my entities, for my aggregate roots, I have ID. Let's switch to our basket. This is going to be my aggregate root. The aggregate root is a biggest entity. The aggregate root is a special form of entity. When you go to definition of your aggregate root, you actually see that my aggregate root inherited from entity. So you have entity, the same entity, but in this entity, you may encapsulate, you may orchestrate multiple entities. Okay, so please focus in domain-driven design, mostly focus on your domain layer first. After handling all this stuff, we are ending up with like separation of concerns. You have separated the business logic into, you are encapsulated your business logic into your entities, value objects, aggregate roots. That's great. But how can I make sure that they will work together? Because part of my logic is inside basket, another part is inside my coupon. So how I can make sure that they can handle one user story? That's why in our application, in our clean architecture, we have, let's say, application layer. Let's call it application layer, okay? Here I have a separate folder called baskets. I have used CQRS, but it is not a case here. Domain-driven design doesn't depend from the architecture, doesn't depend on architecture, doesn't depend on CQRS, doesn't depend on the modern technologies that you use nowadays. It is a separate concept, okay? It is a software development approach. It is a methodology. So in my case, I have commands, and I am encapsulating the logic related to use case inside these commands and queries. Great. So you see, I have quantity. I'm creating this quantity. I'm creating the seller. You see? So let's go to the definition of the seller. Seller is an entity. Great. I need to work with quantity also. Let's go to definition. Quantity is a value object, you see. And that's why we are bringing them together in another higher level called application. In this application, we can use different entities and make sure that they are working together. Okay, and we are using repository parent to store our information. This is really important. You already know about repository parent. I'm not going to dive into details. So how you are storing, how you are retrieving data in your application layer using the repository stuff. Okay, that's good. And all the concepts related to your user story, you should wrap it to your application layer. How about infrastructure? How about Apache Kafka, messaging stuff, RabbitMQ, all this cool stuff, just encapsulate them inside your infrastructure. You see, I have infrastructure, I have Kafka integration, even publisher, all this stuff like message sending, like the external libraries that need to be used by this application should be encapsulated to your infrastructure because they are a part of infrastructure. Okay. Persistence, let's say we have repositories, basket repository implementation should be inside your infrastructure, but the contract, let's go to our contract, go to definition. So you see the contract is inside application. Okay, the contract here, but the implementation is a bit above in your infrastructure layer. That's the easiest one, I guess. And of course, how you are retrieving the data, of course, using the controller stuff. That's up to you. That's why we encapsulated all this stuff in a separate library, because you can use it for your WPF application, ASP.NET Core, MVC, Web API, I don't know, for your, let's say, mobile-based applications, in all sorts of applications, okay? For my API, I have simple controller. So you see, I have base controller. Why I have base controller? Because I'm encapsulating all this logic to a result-based parent. So I have the easy factories to interact with the responses like 404, 400, 401, and etc. But this logic completely is not related to domain-driven design. It is about the exact technology. And my basket controller, I'm designing it like I'm just using with Web API. So I have sender, using the mediator here, the sender, we are sending the query. We are encapsulating all this logic into either query or to command, okay? And that's how we are interacting with our lower layer. So we have API sends request to the application. In your application, you have query handlers, you have command handlers, and these command handlers actually calls the domain layer elements like your entities, value objects, aggregates, etc. Great. In our case, you see, we are just separate the exact logic, because when you work with lower layer, your higher layer should not know information about your lower layer. That's why if you need to interact with exact status codes, don't move this logic to your application layer, or don't move the application layer logic to your controller. They should be completely separated. That's why we are using commands and queries. And this stuff like separating to command queries helps us to easily extend our application. For example, we are actively using domain-driven design for ERP-based for the applications which have a lot of business logic. And in this case, if you are adding the business elements fast, the CQRS will help you to handle it, because you are not going to every time modify the service layer, every time change something, and it will definitely affect your application performance plus your unit tests, etc. And of course, we have unit tests here. I have tried to do my best when I implemented this project, and I hope after exploring all this stuff, you will learn more about unit testing, because I have implemented, let's say, the best version of writing unit tests here for domain-driven design application. It includes a lot of cool parents, and you can read more about it, about the technologies, about the design parents. So you see, we have applied CQRS, result parent, decorator, mediator parent, publisher, subscriber, strategy, template, factory, chain of responsibility, unit of work, and more and more. Here we have approximately 15, 16 design parents and the best practices related to domain-driven design, of course. So that's simply it. That's simply how you can apply domain-driven design in practice.